Hello, this is Mr. Huber. In this lesson, we're going to look at logarithmic functions and inverses and how we can write inverses of logarithms using what we know about them related to exponential form. So recall that inverse is switching inputs and outputs. They take the domain and range, we switch them, and we have an inverse. And we're going to see what that looks like here with logarithms. Keep in mind what the definition of a logarithm is, how we can write a logarithm as an exponential, right? Taking the base, the x power equals whatever this argument of the logarithm is. So when we come down here, we want to find an inverse for this function. Okay? The first thing we want to do is switch the x and y, the domain and range, the input and output. Okay? So remember, f of x is just a fancy way, if you will, of writing a y. So this is the same thing as y equals log base 3 of x. So the first thing we're going to do to write an inverse is we're going to switch the x and the y. So we're going to have x equals log base 3 of y. And now we want to solve this for the y. We want to get a y equals out of this after we switch x and y. This is an inverse, but we want the inverse as a y equals equation. So we can write this now using what we know about logarithms as exponentials. So we can write this as 3 to the x power equals y. And there's our inverse. Or the inverse notation we could write as f inverse of x equals 3 to the x. So that's our inverse. It doesn't matter which way you write it. Your inverse there is we switch to the x and the y, and the way we get this solved for y is to write it as an exponential. Okay, logarithm is an inverse of an exponential. So we're going to see where we can use that when we come over here as well in the second example. Okay, the first thing we want to do is switch the x and the y. So we're going to have x equals log of y minus 5. Okay? And now a key thing here to remember is this logarithm has a base. Even though there's not one written, when we don't write one, it's the common logarithm is a base of 10. So there's no 10 written here, but there is a 10 there. So when we rewrite this as an exponential, okay, we can write it as 10 to the x equals y minus 5. Okay? Remember, there's a base 10 right here. That if there's no base written on a logarithm, it's a base 10. Right? That's the common logarithm base. And now we almost have y by itself, but we do need one more step. We can add a 5 to both sides. Add a 5 to both sides. We have 10 to the x plus 5 equals y. And that would be our inverse of that logarithm equation we started with. So y equals log x minus 5 has an inverse of 10 to the x plus 5 equals y. Over here, f of x equals log base 3 of x has an inverse of 3 to the x. All right, so we can use this here. We're going to see where we can do it with graphing and some other things we want to do where we want to work with inverses. Okay, remember domains and ranges switch. So if we know the domain and range of one function, the domain and range of its inverse are just switched. All right, we can keep that in mind, something we can use as well, and we'll see a graph in our next example. But first, a little royal relief. What is the only U.S. national park in Michigan? So the only United States national park that's located in Michigan, you got to go far from where we are to get there. It's Isle Royale National Park. It's this island right here. Okay, and actually Isle Royale National Park is this main island, Isle Royale, and 450 surrounding smaller islands. There's a bunch of little tiny islands around here, but Isle Royale itself is a very large island. It's one of the largest in the United States. Okay, it's actually the third largest island in the contiguous U.S. So that's pretty impressive. It's a large island. It's about 45 miles long and 9 miles wide. And here in the next picture on the right, you can see a picture of it. It's really just pristine natural wilderness. The only way to get there is some ferries from, up here in the Upper Peninsula and over from Minnesota. You can take ferries over there. There's really no lodging on there. There's a small cabin and then some people who do backpacking and outdoor camping and things like that. So it's really one of the great places of wilderness here in the United States. I've never been there myself. I'd love to be able to see it and check it out. It looks pretty awesome. But anyway, it's the only U.S. national park in the state of Michigan, Isle Royale. Okay, let's look now how we can use inverses to graph a logarithmic function. So we have y equals log base 3 of x. Sometimes we might think, oh, we just plug in numbers for x. But your calculator won't work with a base 3, right? If you put in log of some x value, it's going to use base 10. That's different than the base of 3 that we have here. So we can actually write this as an inverse to start. So the first thing we're going to do is switch x and y. So we have x equals log base 3 of y. And then that we can write as 3 to the x equals y. So I could get a table of values for 3 to the x equals y. So I can put in some x values and get some y values out. Okay. So like we did when we graphed these before, we can use -2, -1, 0, 1, and 2. You can use your calculator to get these values, that's fine. So I put in a -2 in there for x. 3 to the -2 is 1 over 9, so 1 over 3 squared. Then we have 1 over 3. I put in a 0. 3 to the 0 is 1. Anything to 0 power is 1. 3 to the first is 3, and 3 squared is 9. So that would be a table of values for this inverse. This is the inverse of the log that I started with. Okay? So recall, inverses just means switching x's and y's. Let's look at what this graph would be like first if we graph this. It would go through 0, 1 right here, let's say. 1, 3, 2, 9. We have those negative values, -1 and 1/3 right down there, and then close to 0. So we'd have a graph, right? We've seen this before with our exponentials. That's what our graph would look like. Okay. Now, to graph the logarithm, base 3 to the x, okay, if it's an inverse of this, that means these x's and y's are just switched. Okay, so if I want to graph this equation we started with here, okay, the table of values for that would just be the table I had but switched. So 1/9, I don't know, 1/2 to 1/9, 2. I was getting ahead of myself thinking about the -2 I'd have there already. So I'd have 1/9, -2, 1/3, -1, 1, 0, 3, 1, and 9, 2. So let's graph those points. So I'll start from the bottom up. 9, 2. So we'll go over to 9 and up to 2 right there. 3, 1 right there. 1, 0. Okay. 1/3, -1 right around there. And then 1/9, -2. Again, really close to 0. And so we're going to get a graph that looks like this. It's still a curve, and it's going to be a reflection across this line. If I put the line y equals x in there, right, because x equals y, I was switching x and y to get a inverse. So we could flip that red graph over that kind of green dashed line there, and it would give us the blue logarithmic graph. So you can see what the general form of the logarithmic graph is going to look like. Okay, they should look generally like that. It can sometimes help to graph the exponential, okay, right, the inverse we had here. So get your inverse and use it to get a table of values, and then just switch all the x's and y's. And you've got your x's and y's for the original equation. It's the inverse, where the inputs and outputs are interchanged. Okay? And then we talk about the domain and range. Well, let's look at the domain and range of our original inverse that we graphed. So the domain for this is all real numbers. Okay? All real numbers. You can have anything you want for an x. And the range, okay, is y is greater than 0, right? All of our y values for this are above 0. You'll never get a y value of 0. Okay, y will always be some positive value. If you take 3 to any exponent, you're going to get some positive value. Okay? So what does that mean for our domain and range of this function right here? So the domain and range now for this equation, y equals log base 3 of x, is going to be the interchange of the domain and range, right? It's the inverse of what we had in red. So the domain, okay, it's not y is greater than or equal to 0, it's x, because domain is x value is greater than 0, right? So I just take this. The range here is the domain down here. The only thing that changes, the y and the x change, right? And so then what do you think our range is going to be? Well, if the domain was all real numbers, the inverse has a range of all real numbers. Okay, right? Our y values could go forever. They go down forever, and this graph would keep going up and up and up. The y values could be anything I want. The x values, though, would have to be greater than 0. I'll never have an x value that's 0 or less than 0. So keep in mind how we can use inverses here to help us get our graph, okay? And then interchanging those domains and ranges gives us the points to graph for our logarithmic function, and also helps us figure out what our domain and range are for our logarithmic function. Lastly, let's look at what a transformation would look like of a logarithmic graph. So here we have log base 6 of x minus 3 plus 8. So this is just like when we shift graphs left or right or up or down, any other time we've seen it, only now it's got a logarithm in there instead of some other exponential or quadratic or whatever else it might be. Okay? So this x minus h, keep in mind, right, it's x minus h when we have our general form, x minus h, and then plus k. So the h is the horizontal shift. In this case, it's translated right 3 units and up 8 units. Okay? Remember the minus 3 here, it's a minus in our equation standard transformation, so minus 3. The h value is a 3, a positive 3. The k value plus 8, so our k value is an 8, so it's going to the right 3 and up 8. So that type of transformation is the same as we saw with exponentials or other types of graphs as well. Right? So keep in mind what an inverse means, how we can write logarithms and exponential equations with one another. They are inverses of one another, so we can use that to help us write the inverses, get graphs drawn, understand what's going on with domains and ranges as we continue to work with these new types of equations and graphs for logarithms.